Redmond High School Pre-Calc presents Jethro's foray into the Arctic regions of polar coordinates. The goal is to explore the subject of polar coordinates and how to convert them to and from rectangular coordinates. Hello, we're here in the North Pole with Jethro, a lonely polar bear. So, Jethro, I heard you're searching for a magical rainbow.
Well, I know exactly where it is, but that's the problem. You see, it's at -2,2√3 on this rectangular map of the North Pole. But since I'm a polar bear, I can only think in polar coordinates. Polar coordinates are made up of two parts. The first part is the length of the line from the origin to the point. And the second is the angle of the line. Too bad this is in rectangular coordinates.
Greetings from the South Pole. At the other pole, we've learned how to convert from rectangular to polar coordinates. Here, we have a rectangular map of the North Pole. There's your wonderful rainbow, and that's us at the origin, the North Pole. However, we need to find out its location in polar coordinates. First, we need to find r. We can do this with the Pythagorean theorem. Since the sides of this right triangle are 2 and 2 times the square root of 3, we can write it out. 2 squared plus 2 times the square root of 3 squared equals r squared. Using basic math, you should know, Jethro, that we can find r to be 4.
But polar coordinates have two parts, Gregory.
I'm getting to that. The second part is the theta value of the angle. We can find this by the relationship of y to x using arctangent. Arctangent of -2 times the square root of 3 divided by 2 equals -π/3 radians. This is our theta value in the coordinate.
That's great, Greg. What about converting to the other way?
Elementary, my dear Jethro. We just plug whatever angle we have into cosine and sine. Because y and x are equal to r times the sine of theta and r times the cosine of theta, we simply plug -π/3 radians into these definitions. Y equals 4 times the sine of -π/3, and x equals 4 times the cosine of -π/3 gives us y equaling 2 times the square root of 3, and x equals -2. So there's your rectangular coordinates back again, Jethro.
Well, thanks, Gregory. Time to go find that rainbow. Wait! We're going the wrong way! See? We're going to the fourth quadrant, but the rainbow's in the second quadrant.
Oh yes, Jethro, I forgot. Polar coordinates can be expressed in 4 different ways. We're going at -π/3 radians for 4 miles. However, we're going the completely opposite way. That's because our angle is off by a whole pi radians. Since we're going the opposite angle, we should go the negative distance. In other words, we should go to -4 π/3.
But what about the other ways to say it?
Well, -π/3 radians is the same as 2π/3, -4π/3, and 5π/3 radians. Depending on which quadrant it's facing, we'll have to change our distance accordingly. We'll be going 4 miles backwards if we're heading for -π/3 or 5π/3 radians, but we'll be going 4 miles forwards for -4π/3 and 2π/3 radians, since the rainbow is in quadrant 2.
You're a lifesaver, Gregory. Now let's go find that rainbow for real.
The end.